So we'll simplify this first one, -7 plus 3 minus that garbage and some other garbage. So order of operations means that we'd have to do the parentheses first, so 9 minus 2, which is old 7 right there. Then we'd be looking at, well, no exponents, no multiplication or division, but we do have addition and subtraction from left to right. So first up, we'll do the -7 plus 3, which is -4. And then we'll do -4 minus the 7 right there, which is -11. And then -11 plus -8. We're just adding in more negatives on that, so that's going to be -19. And then finally, -19 plus the 20 is going to give us a +1. Let's see, +1 right there. Okay, so that's number one. Number two, same process right here. We'll do the order of operations. We've got to do 5 minus 12 first. Now we're taking away more than we have, so we know we're going to end up in the negatives, and then 12 minus 5 would be 7, so it's -7 right there. Well, we also have that order of in the order of operations, the absolute value, which is 8 times -2. Now that would be -16, except it's an absolute value, so that's just going to end up being a +16 on that one. So we'll just write it as +16. Okay, so not worrying about the absolute values. They change into parentheses now. Okay. Well, we took care of all the parentheses, no exponents, but we do have multiplication and division on this one. With first the -7 times -7, which is +49, and then this one would be 4 times -6, which is -24, and then 3 times 16 looks like that would be 48. And then we got the operations in between these, which is minus and then plus. I got minus and negative right there, so I'm going to make that a big plus sign. And the last thing we're going to do is just addition and subtraction from left to right. So 49 plus 24, that'd be 73. And then the 73 plus the 48, what would that be? 121. 121 is what I got. Right? Yeah, there we go. Got to carry that one over there. Number 3, 45, mixed number on this one. So I'm gonna use long division on this one. It's 45 divided by 7. So a long division would look like this. And we're just looking for remainders on these to change these into mixed numbers. 7 goes into 45. Should be 6 times. 6 times 7 is 42. When you subtract, you get a remainder of 3, which means the final answer would be 6. You had a remainder of 3, and these were still in sevenths. So 6 and 3 sevenths. Next up, changing this mixed number into an improper fraction. I do like cycle method, you guys. So that means I'm going to take 32 and multiply it by the 7, which appears to be 224. And then you add that to that numerator, which is, in this case, 2, which is 226. Now you just keep the denominator the same in sevenths on that one, and we'll call that good. 226 sevenths. And number 5 has to do with the lesson that we had last time about adding and subtracting fractions. So this means that we need to manipulate both fractions so that the denominators match. And the matching denominator that I'm going to use is 35. So again, I'm just looking essentially for any common multiples of 7 and 5, and 35 works. And it also just happens to be the lowest one, not that that matters. So how do I change a 7 into a 35? Well, add multiplied by 5, which means we got to multiply the numerator by 5 as well to make that 10 35ths. And again, it's important to notice that the 2 sevenths and the 10 35ths have the same value, they just look different. So we'll do the same thing with the 5. We'll multiply it by 7 to make that denominator 35. So 4 times 7 makes that 28. And yes, we are adding these two together, which means, and I'm going to show an extra step, not that everyone would need it. We are dealing in 35ths here, but it's 10 and 28 of these 35ths. So we're going to add those together. Not a lot of students show this step right there. It's not required that you do. But it's important that you understand that that is actually what is happening, because eventually when you guys take a different math class, you'll have to go backwards on that stuff and split it up into two separate fractions. So this then becomes 38 35ths. And some of you guys are like, dude, I need to change this into a mixed number. I don't know why you would. I mean, if you're super motivated like that, that's fine. It's just a lot of students will make a small mistake in between changing this into from a improper fraction to a mixed number. So I'm just going to leave it like that. Call it good. I take a minute and copy down the objective. I can multiply and divide fractions. 1 minute, go. So what is 1/2 of 6? Now, we're going to use multiplication to do this, even though it wouldn't be required. Like if someone just came up to you on the street for some reason, it'd be kind of weird. But they'd say something like, hey, what is 1/2 of 6? I mean, you'd be like, don't talk to me, please. But the real answer, of course, and some of you guys know that the answer would be 3. It is 3. Half of 6 is 3. Well, how do we even show this using multiplication? Well, it really is just 1/2, and then it'd be multiplied by 6 on this. Now, so 1/2 times 6. Now, there's more to it than just this because, again, our purpose, our objective for this lesson is to multiply fractions. And some people would look at 6 and think, you know what, that's not a fraction. But one thing you guys need to learn in this class is that numbers aren't always exactly what they show. Or that you actually have the power to manipulate the numbers to be what you want them to be, which is what we've been doing when we add and subtract fractions. So something like 6, again, some students would say it's not a fraction. It is a fraction, actually. It's just over 1. Anything divided by 1 is itself, so we can show it as a fraction as 6 over 1. It's just what we call a phantom one because you don't actually see it. It's there, though, which is kind of creepy, watching all the time. So this is how this would work in terms of fraction multiplication. Is you'd say, well, how did we get 3? As it turns out, with fraction multiplication, you're just going to multiply the numerators and denominators separately to obtain new numerators and denominators. So in this case, the numerator, 1 times 6, is 6. And the denominator, 2 times 1, is 2. Well, that's not 3. Oh, it is. It just looks not like 3 yet. 6 divided by 2, because that's exactly what that means, is 3. So we get the same answer either way. And then that person would give you a high five and walk away, and you'd wonder what the crap just happened. 1/2 of 1/3. Think of it as 1/2 of 1/3. I don't know what the difference is there, but yeah, no worries, no worries. I'm still going to use the diagram, not that you would have to, though. So I've got this bar. It's split up into thirds right there. It's not a very nice bar, but it still works. The thing about this is it says it's 1/2 of that third, and the red parallelogram, I guess, is a third of that bar altogether. So if I cut it in half, I'm going to cut it diagonally because it looks pretty. Well, then I would have just one of these pieces like this one right here. All right. Now the thing about that piece is we don't really know the size unless we were to cut all the other pieces into the same size, and then we would have, as it turns out, 6 size pieces, and that purple one right there only makes up one of them. All right. Now again, going back strictly to the math on this, it would show is 1/2 times 1/3. And again, to find this product, all you're going to do is multiply the numerators. 1 times 1 is 1. And then the denominators, 2 times 3 is 6. So mathematically, we get the same exact answer, but the diagram looks pretty too. So this says, switch around to be 1/3 times 1/2, which would be kind of stated in words. What is 1/3 of 1/2, right? So we can see this diagram has already been split into halves. So I'm only going to focus on one of the halves. And I need to split that half into thirds. Now when I do this, I'm going to split it up this way. And yes, those are perfect thirds, just so you know. Well, it's 1/3 of that 1/2, right? So I'm going to focus on this bottom one. If you guys were like, man, I'm going to focus on the top one, it doesn't matter. It's going to be the same exact answer. And I need 1/3 of it, right? So I'm going to shade in 1/3 of this thing with my orange. I like oranges. But, well, the real question here is, well, how much of the whole piece, like the whole piece that we started with, is it, right? So I say, well, it's one piece. Whoa, I need a different marker on that one. But yeah, it's one piece out of, bam, 6 pieces, right? So that would be 1/6 of what we started with. Now that's the model of this. And so this is actually the foundation of fraction multiplication, you guys. Because this would show as 1/3, just like it did right there, just kind of in a different way, right? 1/3 times 1/2. And again, in order to find or solve this, what you do is you multiply the two numerators, 1 times 1, which is 1, and 3 times 2, which is 6. So mathematically, we get the same answer. And we didn't have to draw any fancy pictures or color it. I mean, I like to color it pretty, don't get me wrong, but it's hard for me to stay in the lines, which you guys can see right there. Unlike when you add and subtract fractions, you do not need common denominators with multiplication or division, right? As we can see in the model, it's more about how much of something is something else, so we just straight multiplication on that, okay? No need for common denominators, otherwise you'll always be simplifying your fractions, which is not always necessary, but sometimes. 2/3 of 1/2. Start with number on the right as the shape. So I've got this shape, and it's been split into 2 parts, right? Now I'm gonna show one of them. I'll shade it a little differently, a little lighter there. There we go. And you know, some people can stay in the lines, but I can't. So there's 1/2 of that shape. Now it says 2/3 of the 1/2, right? So I've got to split this shape into thirds. Oh, I'm going to use a different. There we go. So there we go. So now I split it up into thirds. Sorry, it's not showing up so great. But again, if I split this piece up into thirds, I should split the other one up into the thirds as well, so that I know exactly how many pieces the shape would have been split up into. And I can see, just by counting those, that it's 6 separate pieces. Now it says 2/3 of that 1/2. Well, this one would be one of the thirds, and that would be another of the thirds, which is 1, 2 of those pieces. Now it's not 2/3, it's just 2/3 of that piece. Of the whole shape, though, it's 2 of the 6. Now the thing about this 2/6 right here is you can see, maybe, that we could have split that one piece up, or combined them up into one piece, and then there's a second piece and a third piece. So this actually ends up being the same as 1 piece out of 3, or third size pieces. So again, this brings us up to the straight math on this, which would have been 2/3 of, so multiplied by 1/2. And I'm not showing it like I usually would in class. That's okay. We do it a different way later. But right now, let's say 2 times 1 for the numerator is 2. 3 times 2 for the denominator is 6. There's 6. And then we can see both of these numbers are simplifiable by 2, so we can scale these down. So 2/6, I know it can be simplified because both these are divisible by 2. So it's fully simplified fraction. You know, you can decide if it looks more pretty or not. I think it does, just because the numbers are smaller, I guess. But 1/3 is the same thing because the 6 and 2 are divisible by 2. And it's just like we saw in the shape, right? Each of these 2 pieces becomes 1 piece by itself. And then we end up with 3 pieces where one of them was shaded right here. 1/2 times 1 2/3, converting 1 2/3 to mixed number. To mixed number is like changing them to only blue rhombi. I don't know if rhombuses is correct, but I don't really care. And I kind of assume you guys don't either. So, well, I will use those. I don't know. I don't think those would be considered rhombi. Just parallelograms, I guess. And we got 1 2/3 of them, right? So, yeah, I'll do some shading on this stuff. I'm going to try to stay in the lines, and that failed already, so whatever. But there's 1 full piece that would take care of the 1. And then I need 2/3 right there, right? So I need to split this up into thirds. And these are exactly equal thirds. They're not, but I did my best. And I need 2 of them, right? Now you guys notice that I cut the original first piece into thirds, and that's on purpose, which will help us to figure out what the improper fraction is also. And that improper fraction would show that you'd have 1, 2, 3, 4, 5 of these third pieces, right? So it's 5/3. And yeah, that would be converting the 1 2/3 into an improper fraction, which mathematically speaking is makes our heart feel really nice. Kind of like you had just barely had a cup of hot cocoa, you know what I'm saying? So we got 1/2 times 5/3. So we got to take that. I should do the diagram before I use the mathematics on that. That's okay. So let's use the diagram. I'm going to cut this in half, right? So I'm going to cut both of them in half and just only take half of them. This half and this half. Right? Well, now I've got 1, 2, 3. We're looking at the green. 4, 5. It's still 5 pieces. But we changed the size by cutting those in half, right? Now they are in 1/6 size pieces, and we did it with a diagram, and it's so pretty. I mean, it got kind of messy, but it's still pretty, okay? Well, this is how you would do this with straight mathematics. 1/2 times 5/3. Again, we converted that 1 2/3 into improper fraction. So multiply your two numerators. 1 times 5 is 5, and then the two denominators. 2 times 3, please don't say it's 5. Okay, because it does happen from time to time where we're like, yeah, 2 times 3, bam, 5. And hopefully you guys understand the mistake there. They just added the 2. Don't add, it's multiplication, right? It's 6. And we see that our orange answer matches our green answer. The models match the straight math. I like the math. Well, I like the model, it's pretty. So there you go. So here's two mixed numbers. 1 1/2 times 1 1/3. I've got these two diagrams here. I don't know if they're going to be helpful. But you guys try this one out, okay? I'll give you 1 minute, go. Hey man, I like this problem. I'm going to multiply the mixed numbers, and then you'd realize pretty quick how crappy that is when we talk about just the straight math. So, if you notice that, that's good. We want you to notice that, which means that I need to take both these numbers and turn them into improper fractions, all right? So I'm going to do that with the old cycle method, even though, yeah, your calculator would do it for you. So remember, it's the whole number multiplied by the denominator, which in this case is 2. 1 times 2 is 2. And then plus the 1 up there in the numerator is 3. So this ends up being 3/2. Just keep the denominator the same from the fraction. And then over here it's going to work the same way. It looks like a little bit better cycle method. 1 times 3 is 3. Plus 1 is 4. So this ends up being 4/3. And yes, we are multiplying these two. Now, I told you guys I'd show you a second method on this one. Before we multiply the numerators and denominators, as it turns out, we can actually analyze the values that are given as they are. Here's what I mean by that is I can look at these and I see not only do I have matching numbers with the 3's, but the 4 and 2, 1 in the numerator, 1 in the denominator. If it were a fraction of itself, they could be simplified, okay? Same with the 3 and 3. So we're looking for any numbers that have a relationship, usually with multiplication or division, in the numerator and denominator. It doesn't have to be the same numerator and denominator, by the way. So what I'm noticing here is the 3 and 3, right? Now I can reduce the 3's because 3 is divisible by 3, and so is, as it turns out, 3. That may come as a surprise for some of you. But 3 divided by 3 is 1, and this 3 divided by 3 also is 1. Okay, so I've simplified that out, which is just going to save me a little bit of work after I multiply these out. Now, if you didn't notice, the 4 and 2 could be simplified. You could continue from there, but I noticed it. I know that 4 and 2 are both divisible by 2, so I'm going to reduce the 4 by 2. 4 divided by 2 is 2. And this 2 right here is also divisible by 2. 2 divided by 2 is 1. Now I can multiply the numerators and denominators. So I don't see any of those green and purple numbers that could be simplified. I mean, 1's fine. But what we end up with here in the numerator, 1 times 2 is 2. And then the denominator, 1 times 1 is 1. And as it turns out, anything divided by itself it's not 1, it's itself. It's 2. So this one is 2. So 1 1/2 of 1 1/3, as it turns out, would be 2. 2 full parts, or pieces, wholes, whatever. Alright, so we'll show this with the modeling on this. Oh, actually, I'm sorry. Before I show the modeling on this one, let me show you guys how this would work if we didn't cross simplify right there, right, it would still have been 3/2 times 4/3, which is great. And we said, well, we don't like that cross simplification stuff, right? So you multiply the two numerators together. 3 times 4 is 12, and the two denominators together, 2 times 3 is 6. And then we see that the 12 and 6, well, 12 divided by 6 directly is 2, but both of these are also simplifiable by dividing by 2 to make it then 2/1, which again gives us our final answer right there. So on to the model. All right, so the model, it's 1/2 of 1 1/3, right? Well, let's see, 1/2 of 1 1/3. So I'm going to do 1 1/3 first, right? So I'll shade this in. Right, we have one full piece, I guess, one whole right here. And then the other one needs to be divided up into the thirds, which will be crucial right here. And I know I'm not dividing those exactly into thirds, but that's fine. But what I do want to do is divide both of these whole parts into thirds right there, okay? So, that other piece would include a third, another third right there. It's a third of that piece, right? So what I have shaded in red represents 1 1/3, but it's 1/2 of those, right? So if I were to, let me copy this stuff down. All right, so I need 1 1/2 of that 1 1/3. So 1 1/3, I already have it. I have a whole 1 1/3 right there, right? We're looking at 1 1/2 of these. And as of right now, this is one full piece, all of the 1 1/3. But I need another half of that, right? Now I see that it's 4 pieces. Half of it would be, well, I'm gonna call it these 2 pieces right here. I'll use these 2 right here. Okay, there we go. I feel like that's pretty for some reason. But in any case, those 2 pieces would constitute half of the 1 1/3, but I need to actually attach it on down here. So then I get this other part here in green that's attached to it, and then we see that it actually ends up being 2 full pieces, 2 whole values in that, just like we got up there in this one up. I missed the arrow on that, but you know what I mean. When we look at a division problem, we got a dividend divided by a divisor. Sometimes I get those 2 mixed up, but I may use that vocabulary just a little bit. But with fractions, the dividend is the numerator and the divisor is the denominator. A quotient's just the answer to the division problem, which hopefully we know by now. But this one says 18 divided by 6 means, how many 6 does it take to make 18? That's what division always means. And hopefully you guys remember that if you were actually taught it in elementary when you guys learned about division, because sometimes they're just like, hey, look, 6 divided by 2 is 3. And it's like, why? I don't know. I'm an elementary teacher. So division is usually asking this question, which I think is more relevant and hopefully helps us to understand what the crap is going on. How many 6s is in 18? How many 6s does it take? I'm going to start that over. How many 6s does it take to make 18, right? So this yellow bar, it's been split up into 18 different parts. And so I'd say, well, how many 6s are there? Oh, there's a 6 right there. Found one. And there's another. I may have done more than it. Yep, I did. 1, 2, 3, 4, 5, 6. I got to watch more Sesame Street so I can count properly. And then we got this last 6 right here, right? Did I count too many on one of them? I did. Oh my God.
That is one too many.
Why do you guys wait so long to tell me, man? I know, I'll take responsibility for my mistake. Counting's hard, man. Elmo, he was misleading me last night. I was watching Sesame Street. He was like, look at this, it's 6, and it was 5. All right, 1, 2, 3, 4, 5, 6. Oh, I think I got that one. 1, 2, 3, 4, 5, 6. One. Oh, I had to count that twice. Here we go. This another 6. I think that's better. Well, there's 3 sets of 6s on that. So of course we know that there's 3 sets of 6s. 3 sets of 6 in 18 right there. Okay. Now 1/2 divided by 1/6 would also be interpreted as how many 1/6 does it take to make 1/2, right? So what I would do on this is, see this diagram, and yes, you do not have to use diagrams, but we're asking how many sixths does it make, does it take to make that 1/2? Well, we've got to take this shape and split it up into sixths. Now it's already split into a half horizontally, so I'm going to go with the kind of diagonal business right here. And when I cut this into 3 parts diagonally, and then with the half it makes up sixths. And then we would say, well, how many sixths is that? Is whatever. 1, 2, 3 of them. See, Elmo didn't fail me on that one. There's 3 of them, right? So there's 3 of those sixths to make 1/2. Well, what would this look like if we were to interpret this as just straight mathematics? Well, it's divided, right? So it's 1/2. There's our dividend divided by 1/6, our divisor. How many sixths go into 1/2? And I know the order of that is kind of switched on that, but it's important for you guys to remember and be able to distinguish between the two. Well, how does this work in terms of mathematics and dividing fractions? If they haven't told you yet, I'm going to tell you right now. We never actually divide fractions, you guys, which is great because I like multiplying fractions. So fun. You know, unless I make a mistake, then it's not so much fun. But in any case, we don't like to divide fractions. We like to multiply them. Now, what's going to happen is we're going to keep that dividend the same as 1/2. But if I change the operation into multiplication, then I have to, what we say in the business, this is extraordinarily technical, but it's flipped. I flipped that fraction, right? It's a very unknown word. People don't say it very often. But the more academic word for it is reciprocal, which you may have heard before. It just means flip the fraction, okay? Yeah, I know some of you guys are like, well, I don't like fractions so much, so I say flip the freaking fraction. Okay, whatever, man. It's the same thing. Well, if you were to multiply this, you'd say, well, 1 times 6 is 6 in the numerators, and then 2 times 1 in the denominator is 2. But if you ever get a fraction, you should always at least analyze this a little bit and see if it could be simplified. And 6/2 could. Really, it reads as 6 divided by 2, and 6 divided by 2, bam, is 3. Now, I did 3 in 3 different colors, not really on purpose. Some irony right there, but it's so pretty. It's good. So 1/2 divided by 1/3 means how many 1/3 does it take to make 1/2? It's a good question, all right? That's really what division is always asking. How much of something goes into something else? Particularly that second number, which, if I recall correctly, is the divisor. Not that anyone cares. But in any case, I'm going to take these pieces, and it says, well, how many thirds does it take to make that 1/2? I've already got the 1/2 shaded in red right there, right? Those would be 2 full pieces. So I'm going to split these up, each piece into how many thirds. Well, what I need to do is I need to look at the 1/2, and I need to split it up into thirds, right? If I make a mistake, that's okay. We'll fix it one way or the other. But on this one, I'd say, well, you know what? Just kind of ignore that black line right there. I'm going to make that red. It's not like a pretty red, but it works. Okay. And then I'd say, well, we're going to split this up into thirds, like this. And I know you guys are like, well, that doesn't look like a third. I did my best, all right? The problem is that, all right, we got 1, 2, 3, and then 4 thirds. But then we got this extra piece right there, which is going to cause us probably some problems, I guess. But I know we got four whole thirds out of that. And as a mixed number, that's fine. We just got to figure out what that other piece represents in terms of, I guess, thirds on that. So here's what I would do, okay? Is we got this, we're going to split these all in half right here like this, just like it was before. But I've got to accommodate the third right there. And it's not directly in the middle of that piece. So it's not like it's another half of a third. Maybe, okay? So here's what I'm going to do is I'm going to split this up into thirds. Actually, I'm going to split it up into thirds this way, okay? And then this should maybe help us a little bit. And so now what do I got? Well, again, this would be a third. That's a third. That's a third. And then 3 of these pieces right here would make a third. Yeah, two of those pieces would make a third. That seems, yeah, okay. Two of those pieces makes a third. I'm going to say these two right here. Which is our fourth part, right? Because we got 4. But then, as it turns out, 1 out of the 2 would make the next third. So it is 4.5. But again, I don't really like the mixed number business. So I am going to change this into an improper fraction, because our answer is going to should be shown as an improper fraction. So 4 times 2 is 8, plus the 1 is 9 halves, okay? So it's 9 halves, or 4.5 of these thirds would make up 1.5. Now, let's look at this purely mathematically speaking, all right? Because some of you guys are like, dude, I hated that model example. I kind of did too. So on this one, it's 1.5. Let's write this out, 1.5. And it's divided by 1/3. Okay, directly. And we're not going to use long division as much as you may want to. But again, I'm going to change the 1.5 into an improper fraction, right? So 1 times 2 is 3. I'm sorry, plus the 1 is 3. 1 times 2 is 2, plus 1 is 3. 3 halves. And this is going to be divided by 1/3. Now, here's the thing is, just like I said before in the lesson, we're not actually ever going to divide fractions. We're only going to multiply them. So I'm going to change this to multiplication, and it's so great. You just get to do it. You just can't just do it, though. If you're going to change the operation to division, you got to reciprocate this fraction. Reciprocation means I'm going to flip it. So I put a 2 there, so 1. There we go. So instead of 1/3, I'm showing it as 3/1. Again, this is all part of me taking control of the numbers, not the other way around. And from here, I can multiply this out to get my final answer, which you'll see is 9 halves, right? 3 times 3 is a little 9er, and 2 times 1 is 2. So 9 halves, we get the same answer either way, whether you use the modeling or straight math. Now this one says to draw a diagram. I really don't care if you do, but you're welcome to, okay? There are 15 cars in Eric's toy car collection. 2/3 of the cars are red. How many red cars does Eric have? You guys take a minute and see if you can solve this one, all right? 1 minute go. Okay, so 10 red cars is what you should have gotten on that. But let's use a diagram. We like some diagrams and stuff. Well, we got 15 cars for old Eric on this thing, right? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And yeah, some of you guys are like, well, why'd you do it like that? On purpose. Okay, here's why. Because it says 2/3 of the cars are red. Out of these 15 cars, maybe I should have made 2/3 of them red, but it doesn't matter. Okay, I put them in groups like this to show thirds of the 15, right? So there's a third right. Oh, that's a little bit big on that one. Third. There's a third right there. And there's another third. And then there's another third. Well, only 2 of the thirds are red. So that means that this set would be red. And then this set, that's 2 of the thirds. And that would be, if you counted them, 1, 2, 3, there's 10 cars. 10 red cars. Okay? So that gives us our answer is 10 red cars. Well, that would be using a diagram, and it's so pretty. However, let's use the math on this, okay? Now, we know that this section is about multiplication and division of fractions because that was our objective. However, it's important for you guys to know the difference between multiplication and division when you see word problems like this, because we're going to see some. Now, for a division problem, you'd be looking at something that says how many of something is in something else, which is why we talked about it before. Multiplication, sometimes it's not as clear, but yeah, I guess another way to think about multiplication is that multiplication is usually asking how many of something total there is if you have a certain number of groups of something else. And this is actually 2/3 groups of 15. Okay? So that means it is multiplication. And you would multiply this by, well, 2/3. Well, that looks weird. It almost looks like a mixed number, right? But we don't have to look at it as a mixed number because 15, and some of you guys can see it. You can see it right now. Even though it's not showing it, it's a fraction. It's a fraction. 15 is a fraction. And remember, math is really about forcing the numbers to be what I want them to be, not what they want to be. Which sounds kind of mean, actually. But we need to impose our will on that 15. There's a hidden number there. It's there. It's watching all the time. It's a phantom 1, you guys. 15/1. That's the identity property for division. And we see now that we have fraction multiplication on this. Now I'm going to do this one a little differently because we did that other one where it was 6 over 2 rather. You can actually cross simplify these. Now this is not cross multiplication, which unfortunately we get slightly mixed up. This is fraction multiplication, so we can cross simplify. If I look at numerators and denominators that have common factors, then I can simplify them, right? So 15 and 3, I see a 15 in the numerator, 3 in the other denominator. And it doesn't matter where they are as long as they're in the numerators and denominators. Well, 15 and 3 are both divisible by 3, right? 15 divided by 3 is 5. And 3 divided by 3 is 1. And this just makes the simplification process, sometimes even the multiplication, a little bit more easy. And so, yeah, now I don't see anything is divisible by 1, but you could do that forever. And you'd probably get a little bored of it after about a week. So 5 times 2, bam, is 10. 1 times 1 in the denominator is 1, and 10 divided by 1, yeah, just show it as 10. Make that a phantom 1. And again, you can't see it, it's there. It's kind of creepy, actually, now that I think about it. Read this on this. Nicole filled 5 glasses with 2/3 liter of soda in each glass. How much soda did Nicole use? Take 1 minute and solve this one. 1 minute, go! So on this one, I'm going to start with the diagram. I know you guys, not everyone used it, and that's all right, too. All right, so each glass, which, as it turns out, for me is a rectangle, is going to be 2/3 of a liter of soda, right? So here's 5 of them, though. 1, 2, 3, 4. And yeah, these should all be the same size, but I know you guys don't give a crap either. So, well, I hope you don't. Now, I cut these in half specifically because it's 2/3, right? So if I were to take these and, extend them, the red would include the final third to make a full liter, right? So if I did that, again, my drawings are so pretty, but I'll fill these with, what did it say, soda? We're going to make it grape soda, so that's purple right there. There we go. Now, when I do this, when I fill these all with purple soda, what I can do is I can transfer this third into this portion of the liter. So this would make 1 full liter, right? There's 1 full liter. And then these 2/3 right here, I can move over here to this one to make another full liter right there. See that? And then, right, this glass is empty now, so I'll get rid of that garbage. And then I'm going to take this third right here and move it into this square to make that a full liter right there. And then I'm just left with this piece right here. So I ended up with, for me anyways, I ended up with 3 full liters. And then we ended up with this part right here, which is 1 out of a third, 1/3 size piece, which is 3 1/3 liters. Now again, that's the mixed number, which again, in terms of applications, generally speaking, you would use mixed numbers. However, if we talk about the math specifically, which I'm going to show next, then the improper fraction works much better. So this was 5 glasses of 2/3. As it turns out, it's the same as 5 groups of 2/3, which is why this is multiplication, you guys. And again, since we're multiplying by a fraction, I would want to see the 5 as a fraction, so I'm going to force it to be 5 over 1, not just 5. And from here, I'd be multiplying the 2 numerators. 5 times 2 is 10, and 1 times 3 in the denominator makes that 3. So 10/3, as it turns out, is the same as 3 1/3 if you had converted that already. So 10/3 liters or 3 1/3 liters. Just be mindful that on the homework or the assignment, it may say, I believe most of those it wants specifically you to use the improper fraction. Tyson has been serving 2/3 cup of lemonade to each student. If he has 1½ cups of lemonade left, how many students can still get lemonade? How much of the serving will the last student get? Let's do this one. So Tyson got servings is 2/3 cups, and he's got 1½ cups left. Now it's saying how much of a serving will the last student get, or how many students can still get lemonade, which means it's also asking, even though it's not directly asking this, how many 2/3 are in 1½? And then, yeah, we got to figure out how much is left. So this is a division problem, you guys. Now, before we get into the division part of this, I'm going to use a diagram because it's so pretty. And I need 1½, right? So there's my 1. There's another 1. And we'll split these into halves. So we can see the 1½. And so what is it? It's lemonade, right? So I'll use orange. That seems appropriate. And there's one full cup right there, and then, you know, another half. I feel if I put that in the top, you guys would have objected because, you know, gravity would pull the lemonade down. But in any case, that's 1.5. But we want to know how many 2/3 are in there, right? So I'm going to split this up into thirds. This way. Oh, pan again. There we go. Now I know this splits it up actually into sixths, which is kind of important actually. But I want to know how many 2/3 are in there. Well, we're looking at the purple now, and this would be one serving right here, right, in purple. And we can see that every 2 pieces would constitute a third, right? So 4 of those would be another serving, and well, I'll kind of identify these 4 right there as another third. So there's 2/3, that's 2 servings, that's 2 full servings. I'll write it in, what the heck, 2 full servings. Actually, serving is a long word, so I'm going to write serve. So you get 2 students can still get lemonade, that's that first part, but how much of a serving will the last student get? Well, we know that 4 parts, right, 1, 2, 3, 4 parts, 1, 2, 3, 4 parts, 4 parts would make up a serving. And right here I've got 1 of 4 parts. So there would be 1/4 of a serving left. You know, we'll put left. Now, just so we know the difference. Now, if you were like, well, there's 1/6 of a cup, yeah, that would be true. But it was asking how much of a serving is left, not how much of a cup is left. Very different. So that is how that would work with the modeling. It's okay. It would be, it's how many 2/3 are in 1.5, so it would be 1.5 divided by how many of these 2/3 are in 1.5. Now again, when we're using the straight math like this, it's better to use an improper fraction instead of that 1/2. So again, I would use cycle method on that, even though we can see in the modeling, that'd be 3/2 right there. 1 times 2 is 2, plus the 1 is 3, and then the denominator remains 2. But this is divided by 2/3, and, oh, yeah, we don't actually divide fractions, right? We multiply them. But if we do, we got to reciprocate the divisor there to make that 3/2. So this is 3/2 times 3/2. Wait a second. All right, yeah, continuing. 3 times 3 is old 9er, right, in the numerator. And then in the denominator, 2 times 2 is old 4. And yeah, that would be 9/4, which as a mixed number, 9 divided by 4 would be 2. And yeah, you could say 2/4 remaining, but wait a second. No, 1/4. Man, I need more sleep. So that shows you that you have the 2 full servings that we showed up here in purple, and the 1/4 of a serving left. That's how much of a serving was left. That's the mixed number on that one, okay? And again, that does not tell us the answer in cups. It tells us the answer in servingses. So, you know, whoever gets that small portion of a serving left, I hope they're happy.